Checking answers. Frank had 95 cents. He spent 75 cents on a soda. How much money does Frank have left? In order to find how much money Frank has left, we began with 95 cents that Frank originally had. We subtract the 75 cents that Frank spent on a Coke. We began with the ones column. 5 minus 5 is 0. 9 minus 7 is 2. Therefore, Frank has 20 cents left. In order to check our solution, we would add 75 cents that Frank spent plus the 20 cents that Frank has left. We began by adding the ones column. 5 plus 0 is 5. 7 plus 2 is 9. Equals 95 cents. Therefore, our solution checks out. 95 minus 75 equals 20. Problem 1A. 78 minus 25. We began by subtracting the ones column. 8 minus 5 equals 3. 7 minus 2 equals 5. Therefore, 78 minus 25 equals 53. In order to check this problem, we can check subtraction by addition. We add 25 plus 53. We start with the ones column. 5 plus 3 equals 8. 2 plus 5 equals 7. Therefore, we get 78 here. In our original problem, we began with 78. Therefore, our solution is correct. 78 minus 25 equals 53.
You are at Pennsylvania Station in New York City. You search for the sign telling you when your train will leave the station. The time is now 4:12. Your train to Harrison, New York leaves at 4:29. How much time do you have to get on the train? Let's do the math to figure out the time. The train leaves at 4:29. Time now is 4:12. Let's do the math. So we have to subtract. 9 minus 2 is 7. 2 minus 1 is 1. You have 17 minutes left before that train leaves the station. Besides being a high school teacher, I've been a tool and die maker, foreman, tool designer, operations manager of a large tool, die, and stamping company and machining company. Now I'm the owner and president of 3 companies. I did most of the design work on this hinge tooling. Now over here we have a hinge. Now this is used like in large conveyor belts. And they're both the same, and what we do, we just reverse it like this. And they put the conveyor in here, and then they put rivets in here, and they put a pin through here, and these large conveyor belts like in these big factories, like in coal mines and wherever they're going to transport a lot of big heavy things. And you put a pin in here, and that puts these 2 belts together. So it's called a hinge die, so it allows it to hinge. Now how do you make this? And this I like to show you. The metal comes in, it's a rolled steel, and it's fed into the die, and first it stamps out these holes, puts a little line in here, then it notches this out, then it notches this area out, then notice it bends this tab over here and indents these 6 holes, and then the stamping die comes down and bends this, and then another one comes down and pushes it this way, so it's bent like this here. And automatically, every time the power press comes down, boom, 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 this moves one notch. And then when it reaches this end over here, there's a micro switch at the end, which you can adjust to different lengths. And a solenoid comes in and it cuts off, and it just keeps on going automatically. And that's a hinge die. Now, if that hinge die is off the thickness of your hair. Now you think, oh, wow, that's so thin. But listen, this is your hair. Your hair is approximately 2 thousandths thick. So if you have 32 of these together like this, and some hinges are much larger, that would be 0.032, a 32nd. And it wouldn't work because they wouldn't fit together. So in making tooling like this, you have to be extremely accurate. Now, what's the secret? What is one of the secrets? Because if you make one mistake, you can say, oh, oops, it's off a little bit. There's thousands and thousands and thousands of dollars of time and effort to build tooling like this. The key, and I've spent many, many years as a tool and die maker, the key is double checking and triple checking your work. That's what I learned. Learn to do that as you're doing these math problems. Learn to double check your work. I'm going to show you some other tooling, what tool and die making is. Now think of making a part like this here. Look at the holes on the side, bent, upside down, curved edges around there. Here's another little part. And notice on the bottom there's little flares up over here. And this is relatively a simple thing that I've worked on this kind of tooling. And here they are stacked together. This is for floral picks. They take artificial flowers and they crimp over the edges and they put it into styrofoam. We make thousands and thousands of these floral picks in different sizes. And I used to grind this. It was a precision tool and die maker. And this is the way you made them. They come out flat like this. One on this side, one on this side, and it comes out with that kind of a shape, as you can see. Now here's another interesting piece that's on the whiteboard over here. Let's look at this copper strip that's on this whiteboard. Now this is an electrical connector. A wire goes in here and you crimp this edge over here and then you take a screw and you bolt it down. How is that made? Well, it starts with a plain strip of copper. This is a copper connector. You stamp the holes into it, notice, and then this gets notched out, this little shape. Now let me show you this. This is how we used to make it. We used to make it out of 2 pieces. As you can see over here, 2 pieces. And then we used to have to grind them. That's the way we used to make it. But no more today. We do that with electrical discharge machining. And I have a business called Reliable EDM, and you can look up on the web our company. It's www.reliableedm.com. And now by means of, we just program it in a computer, and by means of a wire, we program it, and we can do up to 45 degrees taper, and we cut this out all automatically in a solid piece. So this is old-time tool and die making, but that's the way we used to do it. So let's continue with this die. And that's this part, this die. Notice over here, it's the same thing. And that gets into here like this. Gets stamped in, comes, and stamps out this notch. Then this progressive die keeps on moving along. Then notice in here, there's a tiny little hole that's stamped. Then notice there's a little notch cut in here. And then it's bent in a U-shaped. Then the stamping die comes down and curls these 2 edges over to make it round. Then it comes over here, and there's another little stamping die that comes over here and cuts it off. And the power press keeps on going, boom, 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 boom. Each time a connector is being made. Each time, boom, 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 boom. And so that's how that little part is made. And think of a car body. Think of all the metal in the car. That's tool and die making. Here's another piece. How is this made? Notice that it's bent over here on the side. That's tool and die making. And it has to be done accurately. Math, addition, subtraction, multiplication, division, and a lot of other math is used. But you have to learn when you're working and doing this kind of work, you have to be extremely careful not to make mistakes. That's why you'll be seeing me stressing, always double checking your work. Learn to get into that habit. You'll avoid making many mistakes. You may ask, what is an electrical connector? Well, I have an example over here. This is a wire. And how do you attach a wire that you cut? Well, there's a connector at the end. And as you can see, right over here is part of that wire sticking out. And it's crimped. And this is very, very tight. And so there's thousands and thousands of these electrical connectors used when you have a wire that you want to attach to something. So that's how electrical connectors are being made.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.